Today we're going to talk about angle relationships and specifically how we can set up equations from angles. So recall that segment problems came in two types. Sometimes we had two parts that add up to a whole. So here's one part, here's another part, they add up to the whole thing. Sometimes we'll have two halves that are equal to each other. This is when we have segment addition. And this is when we have a midpoint. So when we have a midpoint, then the two halves have the same length. But otherwise, we have two pieces adding up to the whole thing, two pieces adding up to the whole thing. Simple angle measurement problems come in four types instead of two types, but two of them are much more common than others. The four types are complementary, when we have something plus something else adds up to 90 degrees. Supplementary has something plus something else adds up to 180 degrees. Addition is when two things add up to some random third thing, which may or may not be 90 or 180 degrees. And congruence is when we have two things that are equal to each other. The ones that are the most common are supplementary and congruence. So these are when we add to 180 degrees, or congruent when they have equal measurements. So what we're going to talk about right now is how to distinguish between these two. So supplementary angles add to 180 degrees, and there are two scenarios where we commonly see supplementary angles. One is a linear pair. So these make a line. They are on the same line, and they are touching each other. Together they make the whole line. So x plus y add up to 180 degrees. Here we have, these are on the same side of the transversal. So they're both underneath the transversal, and they're between the parallel lines, so we say the interior of the parallel lines. So they are same side interior, meaning our two pieces have to add up to 180 degrees. That's how we write supplementary angle equations. If we have congruent angles, there are many more options. We could have vertical angles. So these are on opposite sides of the same intersection, and they're formed from the same lines. So here we have m equals n. Here, these are on opposite sides of the transversal and outside, so we call these alternate exterior angles. And we can say 2t minus 6 equals 4t plus 3. Here we have congruent angles based off the fact that they are corresponding. They are in the same place compared to the vertex, or to the vertices. So that means 8x equals x plus 49. Here we have angles that are, on the opposite sides of the transversal, so they're alternate, but this time they're between the parallel lines, so they're interior, and we still say that they are equal measurements. So once you identify that they're congruent, you set them equal to each other. But if they're supplementary, you say that the two things add up to 180 degrees. So before class, I want you to decide whether each diagram shows supplementary or congruent. So you can say, okay, all three of them represent congruent angles, or all three represent supplementary angles, or you have to tell me which ones represent supplementary angles, which ones represent congruent angles. Thanks.